Let's continue exercise 2.1. We are going to have this sensitivities analysis. So as mentioned earlier, we need to perform the sensitivity analysis to determine the best heat duty that we should use in the flash drum in order to achieve the criteria. Okay. Meaning we have to minimize the heat duty required for the system in order to save the energy, right? So in this case, what you need to do is, because we are asked to vary the heat duty, right? And before we proceed to sensitivity analysis, you have to first change the flash column specification to duty, not the vapor fraction. Okay. Earlier, we have actually chosen the pressure and vapor fraction. And now you have to substitute the vapor fraction to duty. So how to get this heat duty required by the system? So it's actually from your base case simulation just now. You can go to the block results. So under the block section, block V101, so there is a results tab. You can click, then this will turn up. So from here you can extract the heat duty here, and put it in the flash drum specification. So with this, then only we can vary the heat duty and observe our criteria, which is the product specification. Okay, the two specification. One is the hydrogen mole fraction in the hydrocarbon stream, and the other one is the ethylene mole fraction in the hydrogen stream. Okay, so let's go through it. So once you are done with the change of vapor fraction to heat duty in the flash drum specification, so you need to go to model analysis tools. So here, model analysis tools. So under model analysis tools, you have sensitivity. Okay, just click sensitivity, then this page will turn up. So click new, and the ID is the default ID. S1 means sensitivity study 1. So just accept the default name and click OK. So once this is done, then you can see this page turn up. So you need to first include the vary parameter. So we are asked to vary the heat duty because we want to determine the best heat duty, right? So we need to vary the heat duty and observe the product composition. Okay, we cannot use a heat duty which cannot achieve the criteria. We must make sure the minimum heat duty that we use should also fulfill the product criteria. Okay, so just go to vary tab and then click new. Okay, so once you have done this, then you have to include the details of the varying parameters, which is duty here. So you have to this is the default name. The first one is the first variable, first varying parameters. So this is the block variable, because the heat duty is the variable of V101. It's a block, so this is a block variable. You just choose from the drop down list. Then for the block of V101, and the parameters that we choose is duty. Okay. This is a default one, the English unit, British thermal unit per hour. Okay. So what we would like to vary is, we would like to vary from minus 1 times 10 to the power of 8 to minus 1 times 10 to the power of 7. Okay. Make sure the duty that we have put in the specification of flash drum is in between these two numbers. So it must be in between these two numbers. Okay. If it's not, then error will turn up when you run the simulation for sensitivity study later on. Okay. So what we have put in just now is, I think is about minus 2.1 times 10 to the power of 7. So it is actually in between these two numbers, the start point and the end point. So the number of points in between, we set 100. Okay, it's up to you. You can set 1000. Only longer time will be taken to generate the result later on. Okay, so this is a varying tab. So we go further. There is a tab called define tab. So define tab. So under define tab, you have to put in the criteria, the two criteria that we have. One is the hydrogen mole fraction in the hydrocarbon stream. Okay, so just go to define and then you click new. You have to insert the name. So this is a name as given in the tutorial or as given in the PDF file. Okay, so you can follow or you can use your own name. This is hydrogen mole fraction, and then it's a stream. This is a stream variable. Which stream? This is the hydrocarbon product, C1, C2 stream. And which component you would like to observe for the mole fraction. So mole fraction, choose mole fraction. Hydrogen, we would like to observe the hydrogen mole fraction in the hydrocarbon stream. So this is the first defined variable or targeted variable. This is second. So this is a second. Second is the ethylene flow rate. Okay, ethylene flow rate in the hydrocarbon stream. So here we set the second criteria, the ethylene flow rate in the hydrocarbon product stream. So make sure you choose the correct name because you have two. So choose C2H4 flow. So the name that you put for ethylene flow in the hydrocarbon stream. Then again, this is the stream variable. The type here is mole flow now, no longer mole fraction, but mole flow, and it is for C1, C2 stream. And the component that we would like to observe is ethylene, and the flow rate unit is pounds mole per hour. So this is all default. Okay, pounds mole per hour. Okay, so once this is done, then you go to the third tab under the sensitivity study. We have the tabulate tab. You don't need to do anything here. You just need to click fill variables, and the variables will fill up the table here. So meaning we are going to vary the heat duty, and we are going to observe these two variables, these two criteria. Okay, so done. Then we go to the next step. Of course, if all these are done, we can start the simulation. We run the simulation and we check the result. So once it is completed, you can see that the results are available but with error. So what is the reason of this error? You have to first analyze whether you can ignore the error or not. So if you look at the control panel, the message from the control panel after you complete the simulation is saying that the error is actually because of certain error in the sensitivity study. Meaning, if you check the table, the results table under the sensitivity study, the results table, some of the results in certain row here, this is row like 92 to 95, right? The one I have selected is row 92 to 95, is with the status of OK. But if you check the row earlier, let's say from 1 to 80, I think, is with the status of error. So the error here is actually because of that. Okay, then it is actually okay for us to ignore the error. We can check the result. Okay, the results are still applicable and usable. So once we confirm this, we can ignore the error. Then we will go to the table. Okay. And the target here is to identify the minimum heat duty that released from the system while achieving the two criteria. Okay. Let's check. You only need to focus the box that I have put in. So just focus in between row 93 to 95. Okay. In row 95, it seems like we are still not achieving the target, because hydrogen mole fraction must be 0.02, less than 0.02, so no problem. The hydrogen mole fraction, no problem, we fulfill that. I'm referring to 95, row 95. But if you look at the ethylene flow rate in the hydrocarbon stream, it must be 919.25 pounds more per hour and above. So this is less than that. So we know that if we put a heat duty of minus 1.54 times 10 to the power of 7, we are not able to achieve the target. Okay. We have to put at least the heat duty in row 94. Okay. It is minus 1.64 times 10 to the power of 7. Then only we can fulfill two criteria, meaning the heat duty must be minus 1.64 times 10 to the power of 7 and above. This is the heat that must be released from the system in order to achieve the two criteria. Okay, you can put any number further, meaning 1.7, 1.8, no problem, right? So I think that's all for exercise 2.1. I will stop here before we proceed to exercise 2.2. So I hope you can understand, especially on the sensitivity studies. So what you need to remember for flash drum is you should know how to select the flash model, okay, whether flash 2 or flash 3. Then you should be able to know the procedure to include the information for the simulation of flash drum. For the model itself, you have to include at least 2 parameters. So we have temperature, pressure, vapor fraction, and also the heat duty. Okay, you have to choose either 2. So in exercise 2.1, we have selected, especially in the sensitivity study, we have selected pressure and also duty. Okay, so with this, I hope you can remember the key point for the flash drum simulation. So thank you very much.